Okay, today we're going to do something a little bit different than I usually do. We're going to deal with a 532 nanometer green DPSS diode pumped solid state laser, which I built and modified some time ago. Here's the laser head. Completely disassembled, realigned the optics on this module, and also improved the heat sinking on the KTP crystal. So I'm not going to explain that. If you're familiar with 532 nanometer DPSS, then you know what I'm talking about. I built the power supply into the case of a PC power supply and put a red LED fan in there, and even when the laser is turned off, the fan is still running, so that way the MOSFET gets cooled regardless of whether the laser is powered on or not. So here we're going to go ahead and switch the laser on, and I've got a piece of thick, it's about 1 inch thick Lexan here that I salvaged from a dumpster. It lights up pretty nice with this laser. So for now I'm going to turn it off. I want to talk about the goggles a little bit more though. These are Army. They're abbreviated as SPECS, Special Protective Eyewear Cylindrical System is the acronym. And Department of the Army, U.S. Army Natick Research, and they block. I'll show you a demonstration in a second. They block actually over 90% of 532 nanometer radiation, and they even offer ballistic protection. They can stop a 15 caliber steel pellet at 650 feet per second. I'm not sure why you would need that in the laser business, but apparently they wanted to prepare for every possible contingency, and it's got instructions for use and adjustment. So anytime you're dealing with a laser, you always want to wear goggles that are spec'd for the area of the spectrum, the optical frequencies of which you'll be dealing with. Told you I'd demonstrate this. I'm not going to hold the glasses in front of the beam for long, because they actually it actually can act. If you linger in front of a laser beam, you can still have a hole burned in your goggles. They're not intended for you to stare to the beam. So you can see that the only thing that remains is a very faint circle spot on the plastic. So let's remove this. Now let me see if I can carefully aim this. Alright, now you can see that the beam is visible even though I've got the lights on here in the lab. So it gives you an idea of the power. Now let me switch this off before I burn a hole in the desk over here. Okay, what I want to set up now, what I'm going to set up is a laser power meter, but I'm going to go ahead and demonstrate that in the next video, because I need to get a battery, and I did not bring the battery with me, and it's out of reach. So in the next video you can see actually how powerful this laser was, and you'll be able to see a good thermopile based reading via my microcontroller based LPM laser power meter. So stay tuned. 73. This is KI4DBK.